Welcome to the Mathematics Olympiad channel. In this video, we are going to solve another interesting question. This question proposed by Razia for 26 International Mathematical Olympiad 1985. So, the question is factor 5 raised to the 1985 minus 1 into a product of three integers, each of which greater than 5 raised to the 100th power. Okay, first of all, 5 raised to the 1985, we can write this is equal to 5 raised to the 397 times 5. Okay, then I'm going to take n is equal to 5 raised to the 397, and now I'm going to take a expression. We know identity n raised to the 5 minus 1. We can factor this like n minus 1, n raised to the 4 power plus n cube plus n square plus n plus 1. Okay, then it's clear. We have a factor n minus 1 and n is equal to 5 raised to the 397, and this is greater than to 5 raised to the 100 power. Then we have this expression. So if we take this n raised to the 4 power plus n cube plus n square plus n plus 1. Now I'm going to write this expression first as a perfect square. So we can write n square plus 3 times n plus 1 square, but here we have additional terms. So if we simplify this term, we know n raised to the 4 power plus 9 times n square plus 1 plus 6 times n cube plus 2n square plus 6n. Still we can simplify. So n raised to the 4 power plus 6 times n cube plus 11 times n square plus 6 times n plus 1. Okay, then here we have n raised to the 4 power, here also n raised to the 4 power, so it's okay. Then if you look at cube term, here 6 times n cube, but here we have n cube, so we should subtract 5 times n cube. Then here 11 times n square, but here n square, so we should subtract 10 times n square. And here n, here we have 6 times n, so we should subtract 5 times n. Okay, then we can simplify n square plus 3 times n plus 1 square. Now we can take minus 5 times n as a common factor. So here n square plus 2 times n plus 1. Okay, then we can write this is equal to n square plus 3 times n plus 1 square, here minus 5. Now we know n is equal to 5 raised to the 397. So I am going to write, instead of n, 5 raised to the 397, and here we have n plus 1 square. Okay, then n square plus 3 times n plus 1 square minus, now here we can simplify. So 5 raised to the 398 n plus 1 square, then n square plus 3 times n plus 1 square minus, now here we can write 5 raised to the 199, here n plus 1 whole square. Okay, then we have difference of 2 cubes, so we can write factors n square plus 3 times n plus 1 plus 5 raised to the 199 times n plus 1 times n square plus 3 times n plus 1 minus 5 raised to the 199 times n plus 1. Okay, then now we have three factors. First one n minus 1 and here we have two factors, so we can write our expression n raised to the 5 minus 1 is equal to, now we know n minus 1, so n minus 1, then here we have n square plus 3 times n plus 1 plus 5 raised to the 199 times n plus 1, then n square plus 3 times n plus 1 minus 5 raised to the 199 n plus 1. Okay, now we have three factors and we know n minus 1 always greater than to 5 raised to the 100th power, and we know here n is equal to 5 raised to the 397, and also it is obvious that this part is greater than also 5 raised to the 100th power. Now if we take this part, we can take n as a factor, so here n minus 5 raised to the 199 plus 3 times n minus 5 raised to the 199 plus 1. Okay, now we know we can obvious that here this is greater than or equal to n plus 1 and greater than to 5 raised to the 100th power. Okay, we are done. If you like this video, please subscribe this channel. Thank you for watching.